Today we're going to look at another alternate way of processing fingerprints on porous surfaces, particularly on paper for demonstrative purposes today. Also, as you can see, we're set up here. We're not in a venting hood. This is strictly for demonstrative purposes for the class for today. So, as you've seen in some of the other videos, we've looked at indane dione zinc chloride and anhydrine as both options for amino acid reagents. Looking at that component of the fingerprint that is impregnated into the paper, and we are going to use the chemistry that's going to react with this component and develop fingerprints. Now, the technique we're going to use today is diazofluorine 9,1, commonly referred to as DFO. Now, DFO is the first in the sequential process, chemical process of using it in conjunction with ninhydrin. It's imperative that the DFO is used before the ninhydrin. Otherwise, if you do it in the reverse order, the ninhydrin will negate the effectiveness of the DFO. Now, as we've talked about in some of the other videos, the ninhydrin requires heat and humidity to activate the reactant with the amino acids. With the indane dione zinc chloride, it is using dry heat in a heat press, and then it is subsequently viewed under an alternate light source with an orange barrier filter. Much like the indane dione zinc chloride, the DFO also requires the use of an ALS and the orange goggles. What we are going to expect to see today is I'm going to put some fingerprints on a piece of paper. We're going to process it in the DFO, and then we're going to visualize it under normal lighting conditions to see what kind of effect we have. And then subsequent to that, we're going to use the alternate light source and the orange filter on the camera to see how that the fluorescence capability is brought out with the light source. Now, the DFO, by research, indicates that it is 2.5 times more sensitive than what the ninhydrin is. So, for those that are in a mindset that you're only going to use one or the other, you still get a lot of people that prefer just to use ninhydrin because it's been around a longer time, it's more established, it's considered to be the workhorse of amino acid reagents. But I tell people when they use that argument that they're missing fingerprints simply because of the sensitivity of the DFO, that they're not using it, they're missing potential evidence. Now, the process with the DFO is a double dip system. So either brushing, spraying, or submersing it in the exhibit with the suspected prints on it into a bath of the DFO, removing it, allowing it to air dry, resubmersing it again and then allowing it to dry a second time. And at that point, it goes into a dry oven at 100 degrees Celsius for approximately 10 minutes. At that point, what we should expect to see is that some fingerprints may or may not appear as a pale pink color under natural lighting conditions. But when used in conjunction with the alternate light source, and I believe today we are going to be utilizing the 530 nanometer wavelength, so the green light, we're going to use that in conjunction with our orange goggles and, for photography purposes, an orange filter. Now, the excitation on this, it will fluoresce a yellow color when it fluoresces. So let's get started. Okay, so I'm going to put some fingerprints just on this piece of paper here for a moment. And I'll put my glove on. Well, as I said, it doesn't take a lot of time. You're simply just submersing it until it saturates the paper. Just setting it aside. It will evaporate very quickly, and then we can soak it again. Okay, so as we can see, the paper is pretty much dried. It does evaporate very quickly, so we're going to give it its second dipping now. And again, we'll just set it aside for a moment while it air dries. So for our purposes today, rather than using the commercial oven that we have, we're going to do a more close-up kind of demonstration here so you can see it. In this case, we're just going to use our toaster oven. It does have a temperature setting on it. It's kind of a guesstimate as to what it is set at. Ideally, as we said, 100 degrees Celsius for 10 minutes. Now, the issue with this is because the element is so close to where the potential exhibit is, we risk on some occasions that it's actually going to start to toast or to discolor the paper from the heat on the element. But we'll see how we make out here. We'll let that sit for several minutes. Okay, so our 10 minutes has elapsed. We're just going to remove our sample from the oven now. And as you can see, the prints have shown up a very bright, vibrant color. You can see that that certain hue of pink, slightly different than what you would expect to see with the indane zinc chloride. Now from this stage here, we are now going to, under normal conditions, you would be photographing this as it is, proper scale and so forth, and then alternately or additionally using it with the alternate light source and the orange barrier filter. So let's do that now. Darkened conditions, we also have the now affixed the KV550 orange barrier filter to the front of the camera lens. I'm now going to shine the 530 nanometer alternate light source on the surface, and hopefully we'll have some additional reaction. Now I'm wearing orange goggles as well so that I can see the fluorescence, which again makes it easier for photographic purposes so that I can see the setup and see what the fluorescence is. Basically the same as what the camera lens is using with the barrier filter attached to it.